Hello everyone and welcome back to Hall, also known as Teach as We Learn. Today I'm going to be teaching you about arithmetic sequences. So let's begin. So before I go on with the definition and all that fun stuff, arithmetic sequences is literally this. So we started off with 3, and in order to get to 5, you would be adding plus 2. And if you understood that, you understood arithmetic sequences. And to get to the next term, I would add 2, which would give me 7. This is literally arithmetic sequences with just more maybe fancier equations. But going to our real definition, arithmetic sequences is a series of terms where the same number is added or subtracted each time to produce the next term. So here I sketched out a little table for us, and so I'll just write here 1, 2, 3, 4, and 5. So these are our how many times we're gonna add it. But let's begin with our first number. So first number is just gonna be 3, okay? Then our second number is gonna be 3 plus 5. So 3 was the number which we began with, right? So the first number, the number that you began with. And our second number was actually the first number where we added our 5. So what do we exactly do in our third number? Third number, same exact thing, but 3 plus 5 plus 5. So this time we added 2 plus 5s. And then I think you can already see the pattern over here. So here we would do 3 plus 5 plus 5 plus 5, right? We added the number 3 times. And then 5, we do 3 plus 5 plus 5 plus 5 plus 5. So our total output would be, 3 is 3, because we didn't add anything to it. Let's do some orange. So this was 3. This would have resulted in 8. This was 13. Then 3 plus 5 plus 5 plus 5 is 18. And this would be 23. So when we reflect on this, we can clearly see that the number that we're constantly adding is 5. So 5 would be our common difference. Our common difference, or the number that we keep on adding or subtracting, like this is the constant, or this is the number that we keep on repeating. So 5 is our common difference, and 3 was our first number, right, which we started off with. So if I only know these 2 things, then I can make an equation out of it that I can, instead of always just constantly adding 5, 5, 5, 5, 5, I can just do a simple equation with me plugging in my numbers, and I'd get a solution instead of doing this way, which would take forever. Because imagine if we wanted to go find the 23rd number. I would have to add 5 forever, right? If this was the 5th number, so it still work, but imagine finding that 23rd number. It would take forever. So if I could make an equation out of it, it would make things a lot more easier. And a way to make this equation, I'm just going to write it out and then I'm going to explain how we made each part of it. F1 equals 3. Fn equals Fn 1 plus 5. So basically, this is a super random equation. It looks weird, but basically, it's normal, like the equations we see. So basically, this section of our equation is literally just saying that the first number is 3. So that's what it means, that F1 equals 3. And F, you could literally imagine it as Y. Y. That, the first value is 3, right? Like Y equals 3 because even we don't add any number, so it's just 3. Then here, this is literally just Y, X, again, because N is also just X. F is Y, and then you can imagine N as X. And then this part. Now, this is the thing that confuses many people. F and then parentheses N minus 1. So basically what that literally means is, suppose, let's say, we want to find the second number. So I would just say, and we just ignore this and just multiply 2 times 5, and that would give me 10, and we would plug in the 3. Okay, I got 13. But 13 is not the second number. That's our third number. So what basically N minus 1 is, thing that it's there, it's basically saying, because the first number, we never multiply, add, or subtract anything. We only, we just leave it alone. So that's why there's N minus 1. So if I want to find my second number, then I'd do 2, right, X minus 1. So it would be 2 minus 1, which would be ultimately 1. Then I'd do 1 times 5, because yes, we're adding 5, but that's only happened when we're doing this. We keep on constantly adding 5. But if we want to do the quick way, then we would just, multiply 5. So it would be 5 times 1, which is 5, plus 3. So 5 plus 3, which is 8. 8. So that is reality, our second number. So that's how our equation works, and I know that's just super weird, but it's something you'll get used to. So maybe let's actually plug it in. So let's say, F1 equals 3. And then F, parentheses N, equals Fn minus 1 plus 5, right? So that's our equation. So when we actually, let's say we want to find our fourth number. So F1 equals 3, Fn equals Fn minus 1. So that would not, instead of N, we'd replace 4 minus 1 plus 5. So this we can already do, some subtraction, becomes 3. And then we take this, and this, just keep in mind, y'all, that we're not adding. Yes, we add when we're doing tables, but here we would just multiply because we want to do the fast way out, right? So 3 times 5 would equal 15. Then we add our 3. And we would get 18. And was our fourth number in reality 18? Yes, it was. So that's how we know our answer is correct.